In these examples today, we're going to look at how to write or represent logic statements. We're going to look at two kinds of statements today. So compound statements can involve either conjunction and disjunction, which are very closely related, as well as conditional statements. So let's check out some of these examples. So if I look down, I'm writing down on my tablet, so you can follow along if you printed out this organizer for your use. So compound statements, they're always going to be formed by two or more statements with connectors. So two or more statements with connectors. And so depending on what type of statement we have, we'll have a different symbol that we're going to use. So statements can be represented by letters, not unlike variables, except when we're doing logic, we usually use P's, Q's, and R's instead of X, Y's, and Z, because the X and Y's, and sometimes Z's, could be used with graphing. So we want to keep those two topics a little separate. So some symbols that we're going to use, we might use an up arrow, and that has two meanings. So that either means and, or we could call that a conjunction. We have a down arrow, which stands for or, also known as a disjunction. We have what looks almost like the tilde when you're talking about Spanish class or putting above an N in Spanish, and this is called a negation. You can almost think of it as an opposite or a negative. So it is Tuesday. The negation of that would be it is not Tuesday. We have the symbol with straight arrow, and that's something that we're going to be looking at in terms of conditional statements. So we'll come back to that again, but we'll use that if some statement, then another statement. And we'll look at that second half of this video. The last type of symbol that we might have today that we're looking at is these three little dots. And we'll use that a lot more when we start looking at whether or not we have true statements or what kind of proof we can do with those statements. So we'll come back to that statement on another video, but those three dots mean therefore. So if it used in context, this is true because, or we have the statement, therefore, we know this other statement is true. So let's look at conjunction and disjunction examples first. So again, this is using and or statements. And we could also use our letters P, Q, and R to stand for other statements completely on their own. So we have three statements that we're going to practice with. First statement is B, the Beatles were cool, because they were, singing group. Q is September has 30 days. And R, which is a rectangle, has 4 sides. Now, with all of these, again, you might look in terms of whether these are true or false statements. We're going to look at those on our next lesson, but right now we're just looking at translating. So if we have the symbols or kind of abbreviation P and Q, again, that and, well, we can use that with the up arrow. So in symbols, we could also write P up arrow Q, or P and Q. And if we were to write this out, again, we're just substituting in the statements that were given for the P and the Q. So this statement would be written, the Beatles were cool. Oops. And September has 30 days. Our next example has that squiggle with the P, an or, and a Q. So if we did this just in symbols, again, that or, we can use a down arrow. So that would be squiggle or negation, P, down arrow, R. So when we have that negation symbol, again, it means we're talking about the opposite of that statement. So squiggle P or not P would mean we throw a not into the statement, the Beatles were cool. So we would write that as the Beatles were not cool. Or our statement R, a rectangle has 4 sides. So a rectangle has 4 sides. Okay, example 3. And again, if you need to at any time during any of these videos, pause if you need to write something down. You can always too, if I'm speaking too fast, you can always rewatch the video, or if you have the option available, you can always slow down the speed a little bit if you need to. That's why we're doing these videos this way rather than me having you go along with me in a Zoom meeting, which we will do sometimes. Okay, example 3. The Beatles were cool and a rectangle has 4 sides. So first off, we want to write this, or this is just to write in symbols. We already have it in words. So this is where I'm going to practice kind of identifying the pieces of my statement. So I have this and piece in the middle, and I already know that that means the same thing as an up arrow. So then all I need to do is figure out what are the variables that stand for the Beatles were cool and a rectangle has 4 sides. And we actually used both of those in our previous statement. So the Beatles were cool. That's going to be the same as statement P, which you have at the top of the chart. And a rectangle has 4 sides. Well, that was our statement. So if we translate from words back into symbols, that goes a whole lot further. And again, if you need to, you can always mark the Beatles were cool. That was your P statement. And a rectangle has 4 sides. That was your R statement. So go ahead and pause the video and try out number 4 on your own. So looking at number 4, we have September does not have 30 days. So I have that not statement in there. So I know I'm going to probably have the negation compared to whatever our statement was. And our original statement, so if I scroll back up to the top of the chart real quick, September has 30 days. So if our statement is September does not have 30 days, he needs that squiggle. And that was statement Q. Our or, we always use our down arrow. And the Beatles were cool. That was our P statement. Alrighty. So the other kind of statement that we need to talk about very briefly today is conditional statements. So we might have some statements that have and or stuck in the middle. Conditional statements are structured a little bit differently. So these are statements that sound like if, then. So these are always written in the form if, well, most of the time written in the form if then, and we'll look at a couple examples when they're not. We could also write it if P, then Q. And we could also do this in symbols, and this is where that arrow comes in. So we could say if P, then Q. But most traditionally, and this is the one I want you to circle or star this, in symbols, it's going to look like P, arrow, Q. That's how you're going to see this most often. And so again, we need to practice translating that a little bit. Keep in mind there are 2 parts to this, the part that goes with the if, the part that goes with the then. So the phrase immediately following the word if is always called the hypothesis. And the phrase that follows immediately after the then is called the conclusion. Again, these do not include the ifs and the thens, so pay very special attention to the examples we're about to do with what I'm identifying as the hypothesis and the conclusion. Alrighty, so next set of examples. So we have 3 problems here. We need to identify the hypothesis and the conclusion, and then we're going to translate it into symbols. So if a polygon has 6 sides, then it is a hexagon. So again, we don't really pay attention to the if in terms of identifying what that hypothesis is. So I'm actually going to cross those out. But it does tell me what my structure is. I'm going to use a polygon has 6 sides. That's the hypothesis. It is a hexagon. That's our conclusion. And think about those words, hypothesis and conclusion. You can technically use any letters that you want to identify what's going on, but we usually use P for the hypothesis and C for the conclusion, because if you think about the sounds of the words, hypothesis has a very strong P, and conclusion has a very strong C at the beginning. So we would map this out as P, arrow, Q. So our next statement, number 6, if points A, B, and C lie on line W, then they are collinear. So this looks a little confusing because, well, shouldn't we have just one idea for hypothesis, one idea for conclusion? But if we can kind of put those together in one summary idea, we can count them as one statement. So again, I'm going to ignore the if, but that tells me the next piece So all of points A, B, and C line on line W, I'm going to call that my hypothesis. I'm going to ignore the then, but it tells me they are collinear that comes right after it. That's the conclusion. And again, each one of these, you should be able to say this as a statement without waiting for someone to finish that sentence. When I say a polygon has 6 sides, you're not waiting for me to finish the sentence. When I say if a polygon has 6 sides, you're waiting for me to finish that idea. So that's another way to think of, is it the hypothesis or conclusion? And again, we can just label this if P, then Q. So go ahead, pause, try out number 7. So in number 7, same type thing, ignore the if and the then for the moment. So that means right after the if, that's our hypothesis. So our hypothesis is angles add to 180 degrees. They are supplementary, that's our conclusion. And you'll notice I actually picked geometry statements for these last 3 examples. And we're going to keep using these structures to really explain what we're doing throughout the year. All right, so truth value, whether or not these are actually true statements, we're going to start talking about those in the next couple lessons. But today it's really just about writing out our statements and figuring out which pieces we can call hypothesis and conclusion, and how we can translate back and forth between symbols and other representations. So here's our last representation. So sometimes we're going to have conditional statements that aren't written with if and then, but it's kind of implied in the idea of that sentence. So we could also diagram these out. This is not something that's required, but it might help you think a little bit more about how the statements are related. So our first example, all frogs have warts. So again, this is actually a conditional statement in disguise. We just need to figure out where it is. So let's think about these. So our conditional statements go if, then. Hypothesis follows the if, and that's the first idea we read. Conclusion follows the then, and it's the second idea that we read. So if I take this like that, all frogs have warts, my first idea is something having to do with frog. And I have to play around with my grammar a little bit to make this work, but I know I'm trying to fit this into the if, then format. So I can't just say if frogs then have warts. That doesn't make sense. But if I say if it's a frog, then it has warts, that makes a little bit more sense in context. And again, you can play around with the grammar. If I have you write out a statement like that, I'm not going to be concerned so much about the grammar as do you have your if and then, and do you have your ideas in the correct order? Now we can also map this out. If we think about what's the bigger group, frogs or warts? Are frogs the only things that can have warts? Unfortunately, humans can get them too, especially if they pick up a lot of frogs or toads. So we're going to use that as our group. So our conclusion, our then, our warts is kind of a bigger encompassed group. So I'm going to put that in the larger Venn diagram. So frogs are kind of a subset of that. So if it's a frog, then it has warts. Well, we could have other subsets as well. Humans could have warts. So we could be another group in this diagram if we wanted to put that in. So that's one way to think about how to relate the two ideas to each other. Okay, number 9, all candles can burn. Same thing. We're going to have to change up our grammar to make this work. So we need to make it fit the if, then structure to be written as an if, then, or conditional statement in that format. So if all candles then can burn, doesn't make sense. But again, think about how you might tweak that grammar. So if it's a candle, then it can burn. And this works kind of the same way with warts and frogs. What's the bigger group, candles or things that can burn? So bigger group is actually things that could burn. It could be candle, it could be paper, it could be, you know, you're throwing logs on a fire. So candles are kind of your subset. So next one, again, historical quote. This guy named Descartes, who actually had a big role in creating geometry as we know it and math as we know it. So I think, therefore I am. So we have the word therefore, which almost implies we're coming to a conclusion at the end of that sentence. So I think, therefore I am. If I'm going to try to fit it into the if then structure, if I think, then I am. And again, you can think about, well, are we the only thing that exists? Well, no, we have a whole mess of things out in the universe that exist. So let's think about this. Thinking is actually the small group. And if we follow the pattern, the hypothesis is going in this small group. I am. Cats, dogs, favorite pets, rocks, trees, anything that exists can go in that bigger group. Okay, if you need to rewatch this video, take down some examples. You can also look at the filled in copy that I have posted after this video. But do keep in mind the best way to learn math is to write it down. Let me know if you have any questions, and if you're ready to go ahead and finish up the lesson check for this. Again, you have 2 tries on that, so definitely do your first try before the end of class. Second try, you can come back and do that again. I'll take the final score at the end of the unit.